Hello everyone. In this question we have to find the Thevenin's equivalent, that is for this portion which is given inside the box. Okay, so we are excluding RL always, and here see, you can see that there are two independent sources. Till now we have solved problems which consisted only one source, that is for finding the Thevenin's equivalent. But here we have two sources, and let us see like how to solve this type of problems. Okay, so first I will consider this. See here, minus 6 volts. Minus 6 volts is nothing but, if I write like this, it is minus 6 volts. Because this terminal is connected to minus 6, that means it is connected to negative, and I will write it as 6 volts. This is 0.8K. Okay, and here this is grounded. And here again we have 6K which is grounded. Okay, and here we have 4 kilo ohm, and see that this terminal is connected to positive. So this terminal is connected to positive, and the value of that is 10 volts. Okay, that is grounded. Next we have 1.4 kilo ohm, and then we have RL which is connected to ground. Okay, so for this part we have to find the Thevenin's equivalent. Now what we will do is, we will consider a common ground here. Okay, and then we will redraw this circuit. So this one you have to see ground means it is connected to the positive terminal here. So I will write as it is. This is 6 volts, this is 0.8K. Okay, then we have this resistor, I can write 4K, and then we have plus, then minus, this is 10 volts. See, we have 6K which is connected. So if I consider this point as A, this point as A, we have A, between A and ground we have 6K once again, and between A and ground we have this in series. So we can write like this. This is RL, this is 1.4K. So now we have to find the Thevenin's equivalent for this particular part. Okay, for this particular part. So first we can find the equivalent resistance, that is RTH. And you know how to find RTH. So there are three different cases. So first case is where only independent sources are involved. Second case is where both independent and the dependent sources are involved. And the third case is where only dependent sources are involved. And this comes to the first case where only independent sources are involved. So here what we can do is, we can short these two voltage sources. So I am shorting those voltage sources, and I am redrawing this circuit. So this is where we have to find out the RTH. Okay, that is across this particular point, right? So if I consider this as A and B, I have to find it here. So this is 0.8K, this is 4K, this is 6K. So we can see that these three resistors are in parallel. So 0.8 parallel to 4 parallel to 6 plus, okay, all these are K's, plus 1.4K, because after solving this we can say that this one will be in series. This will be our RTH. Okay, so solving this, what we can do, so first I will solve this 0.8 into 4 divided by 4, 0.8 into 4 divided by 4.8. Okay, so this is nothing but 8 into 4 divided by 48. So this we can write at 8 6 are 48, 2 divided by 3. So 2 by 3 is once again in parallel with 6. So 2 by 3 plus 6. So it is 3 2s are, so it is 4. So this is 20 divided by 3. So this is 3 divided by 5, which is nothing but it is 0.6 kilo ohm. So this is 0.6 kilo ohm. So this can be replaced by a single resistor of 0.6 kilo ohm. So 0.6 kilo ohm is in series with 1.4. So RTH will be equal to 2 kilo ohm. Okay, so this is our RTH. Now let us find out VTH. VTH is nothing but, it is the open circuit voltage, where we are opening this terminals A and B. So that means RL will be removed, and we will be keeping this voltage sources as it is. So this is 0.8K, this is minus plus, this is 4K, this is plus minus, this is 6K, and here we have 1.4K. So this is my open circuit voltage or the Thevenin's voltage. So remember here, this is open, right? This particular part is open. That means the current which is flowing through this resistor is 0. Since the current flowing is 0, what happens? The voltage drop also is 0. So the resistor is that only element where we can say that we can observe both open circuit and short circuit together. That means, see, this is open circuit condition where current is equal to 0. This is a short circuit condition where voltage is equal to 0 volts. So open circuit and short circuit both. Yes. So now this is redundant. That means this resistor is redundant because of this open circuit. So now we have to find the voltage across this. That will be your VTH. So see here, I will consider this particular point now. Okay. So here what we can do is, I will write like this. So this is my VTH. Okay. So how can we solve this? Either we can use this nodal analysis. Okay. So let us use this nodal analysis. So this point I will consider all the currents flowing like this. So VTH, here it is minus, so I am taking plus 6 divided by 0.8K plus VTH minus 10 divided by 4K plus VTH divided by 6K. Okay, that is equal to 0. So KK all I will take it out because it will be cancelled if I take it to the right hand side. Okay, so now I can write this as 8 and this one I can write it as 60. Okay, so I have simplified this. So now we can take the LCM of this 8, 4 and 6. How do you take LCM? See, 2 4s are 2 and 3, 2 2s are 4, 1 3. So 2 2s are 4, 2s are 8, 8 3s are 24. So LCM is 24. Here 8 into 3 is 24. So 30 VTH, 180. Okay, and here 6. So I have to multiply 6 in the numerator and here it is 4. So 4 VTH equals to 0. So if this goes to right hand side, we are going to get 0. So I will take this out. Okay, that is 24. See here, 30 plus 6, 36, 36 plus 4 is 40 VTH. 180 minus 60, that is 120, that it goes this side. VTH is equal to minus 3 volts. VTH is equal to minus 3 volts. RTH is equal to 2 kilo ohms. So, if this is the terminals RL, so RTH here I am writing 2 kilo ohm. VTH is minus 3 volts, that's why I will take minus here, then plus here. This is 3 volts. After taking care of this polarity, don't write minus 3 here. Suppose if you had written plus minus, then you have to write minus 3 volts. But here already I have taken minus first, so don't write minus. That will be 3 volts. So this VTH can be found out using different methods. Okay, so here I have used the nodal analysis. We can also use the source transformation. See here, internally it will be towards the positive terminal. So it is something like this. What is the value? 6 divided by 0.8. That means 60 divided by 8 milliampere. And here we have resistors parallel. And again this one internally towards the positive terminal. So it is pointing upwards. 10 divided by 4, that is 5 by 2 milliampere, and here 4K is in parallel. This is 6K. Okay, so this is the VTH, we have to find it out because this is redundant now because of the open circuit. So 60 divided by 8, 230 to 4, right, 225. So this is, 215 and here it is 7.5. So this is 7.5 milliampere. Now to convert this into single current source, see you can see this is pointing downwards, this is pointing upwards. That means they are in opposite directions. So to find out the single current source, we have to take the difference of that. 7.5 and 2.5, that is 5. And what will be the direction? direction will be of the larger magnitude current source, so it will be pointing downwards. So this is 5 milliamperes, and we have already seen that this one will be 0.6 K because 0.8, 4 and 6, okay, that will be 0.6 K. Then we have this one, VTH. See, this current is flowing in this direction, so the voltage drop will be like this. See the polarity, both are different. So VTH will be equal to minus of V.6 kilo ohm voltage drop. So what is this V.6 kilo ohm? That will be 5 milliampere into 0.6. This is 3 volts. So VTH will be minus 3 volts. So we have arrived at the same answer using the source transformation technique also. So we have used the source transformation. We have also used the nodal analysis, that is to arrive at the particular answer. Okay. So this is all about this problem.